Hello everyone. In this video, what I'm gonna do is I am going to um, try um, and see if I can make a, well, I'm gonna go ahead and do composition of functions in this video. So, um, I think in the last video I did radicals and rational exponents. So in this video, what I'm going to do is I'm going to do composition of functions. Okay, so composition of functions is, so let me see, hold on. Give me a second, everybody. Okay, so composition of functions are a different thing. So, okay, so, basically, we must remember that f, so if we have two functions, f of x and g of x, we must remember that f, so the first one is f of x, right? The second one is g of x. There's two things that we must remember. F composited of g of x is f of g of x. Okay? So, yeah, so it's f of g of x, right? So then, and then g of f of x, so g composited of f of x is g of f of x, right? So that's what that means. Now we're gonna go over some examples. And actually, guys, give me a second. Just do it like this. So basically, that's what that means, right? That's what it means. Now, let's see. Give me a second, guys. So we already did the so as you can see here, you see f of g of x, f composited of g of x equals f of g of x. It does not, again I repeat, it does not mean that you're going to multiply them. Okay, it means you're putting one function into another, right? That's what it means. So for example, this one, we're just going to find, for example 1, or let's see, hold on. Or let's go to, let's see, hold on. Let's go to this example, actually. We're just going to find f of g of x and g of f of x, right? So we know that f of x, so we have f of x equals 2x plus 1. And then we also have g of x equals 3 minus x. We're not going to determine if they're commutative. I just want to teach you guys how to do it using composition of functions. So we're going to find f. We're going to do f composited of g of x. Okay, this is equal to, it's going to be f of 3 minus x, meaning that we know that f of x, so f of x, oops, sorry guys. We know that f of x equals 2, it's going to be 2x minus 1. So we're going to plug in 3 minus x for x. So we have f of 3 minus x equals 2. So it's going to be 2 times the quantity 3 minus x minus 1, right? So now you simplify it. So 2 times 3 is 6, so using distributive property, 2 times 3 is 6, minus 2x minus 1, right? And then you have negative 2x plus 5. This is f g of x. Now what about g of f of x? So again, so g composited of f of x equals g of f of x. So we know f of x, so basically we know f of x is going to be 2x plus 1, so we can say g, of 2x plus 1, right? And then we're going to put, so that means we're going to plug in 2x plus 1 in for x, so it's going to be 3 minus x, which is going to be 3 minus, it's going to be 3 minus the quantity 2x plus 1. So then it's going to be 3 minus 2x minus 1, which is equal to 3 minus 1 minus 2x, which is equal to 2 minus 2x. Notice that negative 2x is one term and 2 is another term. You can rewrite this as negative 2x plus 2. So this is g composited of f of x. Okay. Let's see other examples. So yes, as you can see, 7 minus 2x, negative 2x plus 2. I guess commutative just means that they're the same term, so they wouldn't be commutative. And actually, guys, give me a second. Sorry, I meant to put plus 1 here. It was plus 1. So it was actually negative 2x plus 7. Sorry about that, guys. Let's see, hold on. Give me a second, guys. So now we're going to use a table to evaluate a composite function. So I'm going to copy this function down really quick. So give me a second, guys, meanwhile I copy this down. Okay, so in this example, what they want you to do is they want you to use a table to evaluate f of g of 3 and g of f of 3. So first, we want to do, so we have f of g of 3. We want to first look at g of 3. What is g of 3? Right? G of 3 is 2, because when x equals 3, g of x is 2. So g of 3 is 2. You see right here, right? Now, g of 3 is 2, so then what's f of 2? Because f of g of 3, f of 2, so you plug in 2 in here, so f of 2, what is f of 2? F of 2, when x equals 2, f of x equals 8. So f of 2 is 8. So that means that f of g of 3 is 8, right? So that is how you do that one. And then g of f of 2, so we do g of f of 2, or I'm sorry, g of f of 3. This is going to be, so we have f of 3, so when x equals 3, f of x equals 3. So that would go for this number. So basically this number here would go for that one, right? Now, so it'd be g of 3, and then you would say, what is g of 3? G of 3, when x equals 3, g of x equals 2. So g of 3, because right here, when x equals 3, g of x equals 2. So g of 3 is equal to 2. So g of f of 3 equals 2, right? So yes, as you can see, this is how they did it. Now evaluate using a graph, right? Using a graph to evaluate a composite function. So, so this one, you want to evaluate f of g of 1. So first of all, we have to go from the very inside. What is g of 1? G of 1 is equal to 3, is right here. So actually, hold on. Right here. G of 1 is 3. They want to know what g of 1 is first. So what's f of 3? If g of 1 is 3, what is f of 3? Because that's where 3 goes. F of 3 goes there. So f of 3 is 6. So f of g of 1 is 6. Okay. F of g of 1 is f of 3, so f of g of 1 is 6. Right? Okay, so now using a formula to evaluating a composition of functions expressed as formulas with a numerical input. So given, so let's see, given f of t equals t squared minus t, and h of x equals 3x plus 2, evaluate, I think it was f of h of 1, right? So again, you're going to do h of 1 first, because you want to go from the very inside out. From the very inside out. So h of 1 is equal to, so we're going to do h of 1 first. That's equal to 3 times 1 plus 2. So this is going to be 3 plus 2, which is 5. So what's f of 5? F of 5 is going to be equal to the quantity 5 squared minus 5, which is 20, right? So f of h of 1 is 20. Okay? So as you can see, f of h of 1 is 20, because they first did h of 1, and then f of h of 1. So f of h of 1 is f of 5, because h of 1 is 5. They put it in here, and then they got 20, right? So the domain of a composite function, I'll try one of these. But so okay, so this one's a pretty lengthy one. So I'm gonna do f of x. So we have f of x. So let me do it like this. So f of x equals 5 over x minus 1. And then we have g of x equals 4 over 3x minus 2. Right? So we have to figure out what you know, what f of g of x is. So we have to first figure out what f of g of x is to find the domain. Like, we have to then find the domain, but first we have to figure out what f of g of x is going to be. So f of g of x equals f of the quantity it's going to be f of the quantity 4 over 3x minus 2. This is equal to f, so it's going to be 5 over, and it's going to be 5 over x in green minus 1. Sorry, guys. So basically what you're going to do is you're going to do 5 over, it's going to be the quantity 4 over 3x minus 2 minus 1. So then this becomes 5 over 4 over 3x minus 2 minus 1 over 1. We need to get the common denominator. Times 3x minus 2 times 3x minus 2. This then becomes 5 over 4 over 3x minus 2 minus the quantity 3x minus 2 over 3x minus 2. This becomes equal to 5 over 4 minus the quantity 3x minus 2 over 3x minus 2. This becomes equal to... Okay, sorry about that, everybody. This becomes 5 over 4 minus... So it's going to be minus 3x plus 2 over 3x minus 2. This becomes 5 over 4 plus 2 minus 3x over 3x minus 2. This becomes 5 over 6 minus 3x, so it's going to be negative 3x plus 6 over 3x minus 2. So then, sorry guys, this becomes 5 times, so it's really 5 divided by 3x minus 2 over negative 3x plus 6. This becomes 5 times negative 3x plus 6 over 3x minus 2. So this then becomes negative 15x plus 30 over 3x minus 2. So really the domain, so then the domain is all real numbers such that 3x minus 2 does not equal 0. We have to solve for x. 3x minus 2 does not equal 0. So that means that x... The reason why we do it this way, guys, is because on the denominator, there can't be a 0. It'll be undefined. The domain is all your x values. So we have to exclude... We have to make a restraint or a restriction. So basically, that's why we do this. Does not equal 0. So then 3x cannot equal 2. So then x cannot equal 2/3. So that means that the domain of this function is all real numbers. So it's actually from negative infinity to 2/3, parentheses, union, 2/3 to infinity. Okay. Actually, guys, okay. So yeah, this one this one's pretty hard. But we did do the function right. We got negative 15x plus 30 over 3x minus 2, right? So so yeah, basically, that's basically what this video is about. I'm just basically doing composition of functions. So decomposing a function. This is a little bit trickier. It says write f of x as the composition of two functions. So basically, we can write f of x as the square root of x and g of x as 5 minus x squared, right? So that f of g of x is the square root of 5 minus x squared. So that's basically, those are basically the two parts, right? So now we're gonna do some exercises. So we're gonna try to do numbers. So let's try to do numbers 12 through 22, and yeah, so or actually, we can do numbers 11 through 22. So we have f of x. So give me a second, guys. So basically, g of 2, so again, we're going to go from the very inside out. So g of 2 is going to be 3 times 2 minus 5, which is equal to 6 minus 5, which is equal to 1. So then f of 1 equals 2 times the quantity 1 squared plus 1. This is equal to 2 times 1 plus 1, which is 2 plus 1, which is 3, right? So that's f of g of 2. Now, f of g of x is something else. So f of g of x is going to be equal to, and we have, so let's see, we have 2. So we're basically going to put in g of x for x. So f of g of x is f of g of x, which is equal to f of 3x minus 5, which is equal to 2 times the quantity 3x minus 5 quantity squared plus 1. This becomes 2 times 3x minus 5 times 3x minus 5 plus 1. So then this becomes 6x, so it becomes actually 2 times 9x squared minus 15x minus 15x plus 25 plus 1. This becomes 2 times 9x squared minus 30x plus 25 plus 1. This becomes 18x squared minus 60x plus 25 plus 1. This becomes 18x squared minus 60x plus 26. So this is f of g of x. This is what f of g of x is going to be. yeah, so, let's see. Now we have to find g of f of x. So g of f of x, so g of f of x, so let me, part C, g of f of x equals, so it's going to be g of, and I'm going to use this color, f of x, which is g of, it's going to be 2x squared plus 1. We know that g of x is 3x minus 5. So we're going to do, we have g of x equals 3x minus 5. This becomes 3 times 2x squared plus 1, right? And then minus 5. So we do distributive property. We have 6x squared plus 3 minus 5, which is 6x squared minus 2. Give me a second, guys. Okay, sorry about that, everybody. So this gives me 6x squared minus 2, right? So that's going to be g of f of x. So g of f of x is 3x squared, or I'm sorry, 6x squared minus 2. Okay? Now, part D, it wants us to find g of x. So g of x, so let me see, so again, it helps when you rewrite the function. So g of x is 3x minus 5. If we rewrite it in color coding, we can say that it's g composited of g of x is g of x. Okay, so this becomes g of 3x minus 5, which then becomes, so it becomes 3 times the quantity, 3x minus 5, minus 5. This becomes 9x minus 15 minus 5, is 9x minus 20. So that's going to be g of x, right? Now f of negative 2, so part B, f composite of f of negative 2, that's f of negative 2. This becomes, so f of negative 2, if we do f of negative 2 here, so f of negative 2, equals, it's going to be, so f of negative 2 is, so 2 times negative 2 squared plus 1, right? So we have 2, which is 8 plus 1, which is 9. So f of f of negative 2 is f of 9, which equals 2 times 9 squared plus 1, which is 2 times 1, which is 162, plus 1, which is 160. Okay, so that is how you do that part. So now you want to use, so you want to find for number, okay, hold on. Sorry guys, I don't know what just happened. Sorry guys, give me a second, I'm gonna go back. Okay, so the last part of this video, is going to be finding, so I'm literally just going to do all the way through number 19, and then that'll be it, for this video. So basically what we're going to do, so let's see here, hold on. Sorry guys, give me a second. Okay. So, for the following exercises, use a pair of functions to find f of g of x and g of f of x. Simplify your answers. Okay, so for number 12, so number 12 says, so I'm going to copy number 12. I think that's number 11, if I'm not sure though. Number 12, we have f of x equals x squared plus 1. And then we have g of x equals x, the square root of x plus 2. So we want to find f of g of x, or f of g, I think it's f of g of x and g of f of x. Yes. So f of g of x is going to be equal to the square root, so it's going to be x squared plus 1. So it's going to be equal to the square root of x plus 2 quantity squared plus 1, which is equal to x plus 2 plus 1, which is x plus 3. So that's f of g of x. For g of f of x, we're gonna do, so we have the square root of the quantity x squared plus 1 plus 2. Actually, give me a second, guys. It's supposed to look like this. G of f of x. So it's going to be equal to the square root of x plus 2, which is equal to the square root of the quantity x squared plus 1. So it's going to be x squared plus 1 plus 2 is equal to the square root of x squared plus 3. So this is g of f of x. Okay. Now, what about number 13? So number 13, we have f of x. So for number 13, we have f of x equals the square root of x. I think it was the square root of x plus 2. And g of x equals... Oh, okay, yeah. Okay. Sorry, guys, I was just making sure I did both. So g of x equals x squared plus 3. So f of g of x is the square root of the quantity x squared plus 3. So let me color code. It's equal to the square root of x squared plus 3 plus 2. Because for x, basically you do this, right? So this becomes the square root of x squared plus 3 plus 2. This is equal to f of g of x. Now g of f of x, g of f of x equals the square root of, so let's see here. G of f of x is gonna be give me a second, guys. It's because if we have g of x, so if we have g of x equals x squared plus 3, then that means g of f of x is gonna be, so that means that it's gonna be like g of x equals x squared plus 3. So then this becomes the square root of x plus 2 squared plus 3. This becomes x plus 2 square root x plus 2 square root x plus 4 plus 3. This becomes x plus 4 square root x plus 3. So this is what g of f of x is, right? Okay guys, so I think I'm gonna end it here. I do want to do more of these, but I feel like there's just a lot of them. But if you guys have any questions, let me know. I'm gonna do this last one really quickly. So in this figure, we have this function f and this function g. I'm gonna just verbally explain how to do this. So you're gonna do g of 3 first. So when x equals 3 here, g of 3 basically is 4. So then what's f of 4? F of 4 is 0, right? So g of 3 is right here. F of 4 is 0. So g of 3 is 4. So then you're going to say f of 4 equals 0. So f of g of 3 is 0, right? That's how you do that one. Yeah, these problems, and for the table, I think I already did the table. But yeah, these are what these problems consist of. And so with that being said, guys, I hope this video helped a lot. I will be making another video very soon on the next section. So please stay tuned for that. And with that being said, guys, thank you so much for watching. Please like, comment, and or subscribe. And also check out my Discord channel right here, where I do a lot